Hey there, welcome back to our SkyTonight program. My name is Seth Mayo. I'm the curator of astronomy for the Loma Planetarium at MOAS, and I'll again be your tour guide for this program. And in this week's edition, we're covering the dates of November 22nd through November 28th. We're going to start things off by talking about some really cool moon transits that are going across Jupiter during 2 different days this week. Then we'll mention the Andromeda Galaxy. It's really high in our northern hemisphere sky right now, and we'll discuss the opposition of the dwarf planet Ceres that happens by the weekend. So let's get to it. If you're out in the evening just after sunset, the planets Venus, which you find here, Saturn, and then Jupiter are still well placed in the south and southwest. They're great, they're really bright, and again, they look like non-twinkling stars. So with Jupiter in particular, there's something really cool happening on 2 nights this week. First, we're going to start on Tuesday, November 23rd, and this is in the evening, and in the Americas, this is where it will be very convenient to see some moon transits across Jupiter. As we've talked about before, Jupiter has numerous moons around it, but the 4 largest, known as the Galilean moons, can cross over the planet, or at least their shadows can, making it a really cool sight to see through a telescope or powerful binoculars. So with Jupiter, in the evening of the 23rd here, we have it set to about 6:15 Eastern Standard Time. Of course, you have to adjust for other locations, but on the east coast of the United States, this is a very convenient time for this to begin. So we'll zoom in right into Jupiter to see this, at least in a telescopic view here in Stellarium. We'll get a little closer to the planet here. We'll see those 4 large Galilean moons to the right, which are really cool to see there. And there, if we look at the disk of Jupiter, the largest planet in the solar system, beautiful gas planet, on the left limb here, you can see a dark shadow right there. And that is the shadow of the solar system's largest moon, that is Ganymede. So Ganymede's shadow starts first, about 6:15 p.m. Eastern Standard Time. And also, it's situated right above the Great Red Spot right there, that beautiful and large storm, possibly the largest storm in the solar system still, that you can find swirling there as well. And keep in mind, Jupiter spins very fast in only 10 hours, so things move pretty quickly even in a short period of time. So let's speed up time in this view and see what happens here. So we start off with Ganymede's shadow that we see there. We'll continue on as we move along here. We'll kind of move through the 6 p.m. time frame. We'll just go just a little bit faster so we can get into about 7 p.m. Eastern Standard Time. And we have another shadow joining. So what's great is we have a double shadow transit across Jupiter. This time, this is Callisto right there. Callisto is the 3rd largest moon in the solar system. In this case, you'll see it right below the Great Red Spot storm. So we move along here. These 2 shadows can be seen for about a couple hours, maybe even 2.5 hours across the disk of Jupiter, moving into 8 and then 9 o'clock. Again, this is local time here. And as we get to about 9:30 our time here, you'll find that Ganymede's shadow is just leaving this side of Jupiter, this limb of the planet there, along with the Great Red Spot, and you have a little more time to see Callisto there kind of lingering through the evening there. So we'll continue into about 10 p.m. Eastern Standard Time, and then getting into a point as we get into almost 11 p.m. actually Jupiter will be getting really low in our sky in the horizon here. So you wouldn't even be able to see much of that at the end anyway because of how low it is. So that would be kind of nice to have at least those 2 transits happening at a convenient time, at least in the East Coast of the United States. Now, if you are in different parts of the US or elsewhere, you have to adjust your time. And if you're on the West Coast, you'll definitely have to look at this a little bit later or when the transits have already begun. So you won't have as much time to see them, but there is still an opportunity to find them if you go out at the right time. So that's great for Tuesday night, the 23rd. If we fast forward ahead to Sunday night, the 28th, later this week, we have another shadow transit, this time of a bit smaller of a moon that goes around Jupiter, and that is Io. So if we look here, this is 6:20 p.m. Eastern Standard Time. Again, this favors the Americas and again the East Coast because it happens at convenient times in the evening. There you'll find about 6:20 there, the shadow of Io. And in Stellarium, you actually can see that moon situated here as well. And Io happens to be the 4th largest moon in the solar system. It's a really fascinating one. We talked about it some time ago, recently, being this beautiful volcanic world. But anyway, 620, we have the shadow of Io and also the Great Red Spot as well. We can kind of continue on here, and as we do, we can watch Io move across, or at least its shadow move across the planet for a couple hours. If you are in the western part of the United States, you will get the kind of latter part of this happening. We'll kind of center this here, so you won't see the entire thing, but there is an opportunity to see it even there in other time zones as well. So we can see that kind of moving across here, and eventually as we get into about the 8, really 9 o'clock time frame, pretty close to then you'll find Io's shadow kind of move out of view there. So we're doing this in Stellarium, which does a wonderful job of showing not only the position of the shadows, but also the Great Red Spot and where that's located, making for a really cool sighting if you have a telescope and you're looking at Jupiter on these 2 nights. This time of year here in the Northern Hemisphere is one of the best times to see the farthest thing that's possibly visible to your naked eyes, and that is the Andromeda Galaxy. It's arguably one of the most famous galaxies, other than our own Milky Way galaxy that we talk about. And if you do want to find it, it is a little smudge in the sky. Again, it is the farthest thing you can see with your naked eyes at about 2.5 million light years away. So the light from this galaxy takes about 2.5 million years. And that is really, really, really far. But for a galaxy this size, it's actually one of our close neighbors to us. And it's really neat to be able to find. So if we are looking in the northeast, very high up at this time of the year, we can find it. You can kind of see it easily here in Stellarium, but if you are in any place with a little bit of light pollution, it does make it kind of challenging. So you do want to find the constellations that it's near or inside of to find it. Now, of course, Andromeda is named after the Andromeda constellation, which we can find right here. Now, Andromeda is not always the easiest constellation to find. It's the princess. She's the princess of Ethiopia, or the Phoenician princess, and she's located about there. So I can actually draw this in Stellarium so you can see it. And in Stellarium, you just see kind of a little sort of bent line of stars, and then a little bit of stars that kind of come out here. And right at the tip of that is that galaxy. There's a little smudge of light I mentioned, 2.5 million light years away. So the Andromeda constellation is one of the ways to find it because the galaxy sits inside of it. If you want something a little bit easier than finding Andromeda, which is not one of the brightest groupings of stars, you may resort to looking at this constellation. We mentioned it recently. This is Cassiopeia, the mother of Andromeda, the queen of Ethiopia from Greek mythology. So if we look right here, we have this W shape or letter M, but I think of it as a W. And if you do find this W, those stars are relatively bright. We zoom a little bit, there are 3 stars near the top of the W that kind of act like an arrow. So we have this star right here called Navi, this one right there kind of in the middle, this is called Shadar or Shadir, and this one here at the top, that is Kaf. So those 3 stars, think of it as a pointing arrow, kind of point to Andromeda. It's not perfect, but can get you in the right area, the right vicinity of finding this. And if your skies are pretty clear, you have a pretty dark view, you might even see that little blob of light. That's what it will look like, a little fuzzball of light to your naked eyes. But if you do have binoculars or a telescope, you can make this a little easier to see. Usually binoculars are quite useful because they have a wider field, and it may actually help you to find this galaxy with a little bit wider field than zooming really far in. And that is because this thing is so diffuse and pretty large actually in the sky. It actually covers 6 full moon widths across the sky, that something with a larger field of view actually might be a little more advantageous to you. So anyway, we're going to zoom into it in Stellarium here. We're going to click on the Andromeda Galaxy, zoom right into it, and as we do, you're going to see a telescopic view of this beautiful collection of stars we call a galaxy. And it is amazing to see in detail through a telescope or really a long exposure. That's what will give you pictures like this, and people with small telescopes can get views like this. If you have the right equipment, you know how to get long exposures, you can track it really well in the sky. This is fairly possible, something similar to the picture you see here. But of course, the big telescopes around the world, or even the Hubble Space Telescope, can really give us a good view of this. But just talking about this view we see here, we can find the spiral arms of the galaxy here. It is a spiral galaxy, much like our own. And it even has some companion galaxies that you can catch in the view. Many galaxies will a lot of times have companions, sometimes smaller galaxies, or what are called satellite galaxies. In this case, there are two that you can usually find here with Andromeda. You have one right there, that's called M110, and then we have another one here called M32. So those two galaxies are the satellite galaxies or the companion galaxies of the much larger Andromeda Galaxy right here. Andromeda is also known as M31. Just as a reminder, the M means Messier, after Charles Messier, that French astronomer that long ago was trying to decipher between comets and other fuzzy objects in the sky that are permanent, because finding comets was a very lucrative and popular thing to do. If you can discover a comet, you could become quite famous. So these fuzzy objects sometimes look like comets and you weren't sure. So Charles Messier made this catalog of 110 objects. So you have M with a number. And so in this case, M31, M32 I've selected here, and M110. But of course with Andromeda itself, that's the one that really dominates the view. I love seeing it here. Now, speaking of the Hubble Space Telescope, one of my favorite views of all time comes from this picture here. This is a huge panorama that was released about 5 or 6 years ago, and as we sweep across it, we're actually seeing just a part of the galaxy, about 48,000 light years across this galaxy. It starts from the left side, which is the center, the galactic bulge of Andromeda, and as we move to the right here, we're actually seeing some of the dust lanes, the arms of the galaxy itself. And if you see any blue regions, you have blue stars in newer areas and places where there's a lot of star forming going on. If you see redder areas, sometimes those are older stars, been around for a longer, maybe less star birth going on in those parts of the galaxy. And this is a visible light version of this using blue and red filters on the Hubble Space Telescope. And as we look at this, we're actually seeing over 100 million stars, which is truly mind-blowing to realize this picture contains that many stars. In actuality, the Andromeda Galaxy actually may hold up to 1 trillion stars, which is just an unbelievable number, no matter what you're talking about, but especially with stars. And then imagine how many planets could be around those stars. So it's quite extraordinary to think about the sheer size of something like this. But this is the largest galaxy in our local group of galaxies. It spans about 220,000 light years across, as compared to our own Milky Way galaxies, about 100 to 120,000 light year diameter. So it is bigger. The mass of this galaxy may actually be pretty similar to the mass of our galaxy. It's hard to pin down that, but it is the biggest, at least by size, member of our local group of more than 30 galaxies. And Andromeda is actually on a collision course with us. The Andromeda Galaxy is actually approaching our galaxy at about 110 kilometers per second, or 68 miles per second, that we're getting closer to this galaxy. Every second that's happening. But 2.5 million light years away is no small distance. So in about 4 to 5 billion years, we will collide with Andromeda, our own galaxy. And there's a lot of simulations that have come out to show this over a long span of time. Our galaxy and Andromeda colliding. And eventually, as they collide, you'll get this really interesting interaction going on of things flying out, getting brought in, and eventually our two galaxies will become one large, what's called elliptical galaxy. And galaxy collisions are quite common in the universe. That's how some of the largest galaxies in the universe were formed, by colliding with others. And that is happening with Andromeda and the Milky Way over the course of billions of years. So any chance I get to talk about this wonderful galaxy in our sky that, again, is possible to see with your naked eyes if you have the right conditions met, is something I always try to do. And again, if you do want to look for it right now in the northeast, it's pretty high up after sunset. And if you do want to find it, again, finding the Andromeda constellation, or by finding Cassiopeia, the W shape here, kind of pointing towards it, that little blob of light right there in the sky. So I love talking about and looking for the Andromeda Galaxy any chance I get. Coming up this weekend on Saturday, November 27th, we have the opposition of the dwarf planet known as Ceres. And we've talked about oppositions quite a lot through late summer and through the fall, when we had the planets Jupiter, Saturn, and even Uranus and Neptune reach opposition when they're closest to Earth in their orbits, or opposite of the Sun in the sky. This time it's Ceres' turn, and Ceres is a bit challenging of an object to see because it's just outside the range of naked eye viewing. It's at about magnitude 7 right now, and normally magnitude about 6 is where eyes are limited to. That's in a dark location, and the higher number you go in magnitude, actually the dimmer an object is. In case you didn't know already, lower numbers are brighter. So right now at about 7, it is the closest to us, which means it's at its brightest, but most likely brightest through binoculars or a telescope. And if you do want to find Ceres, this small dwarf planet, you're going to have to find it inside the constellation of Taurus the Bull. This is set to the evening of the 27th here, just after 7:30 p.m. local time here. And you'll find Taurus the Bull here, this great wintertime constellation, always noticeable in the sky when it's high enough because you see the V of the nose right here, and also along the back is that really famous star cluster right here known as Pleiades, or the Seven Sisters. So I'll turn on Taurus to give us a better view of it. There you go. Here's the nose of Taurus. Here are the horns, the tips of the horns, the back, and kind of the body. There's the picture of Taurus, in case you want to see the look of the constellation from Greek mythology. So, where is Sirius in relation to Taurus? Well, it's right about in this vicinity above the V, right there. Above, that's called the Hyades star cluster, and this is the brightest star in Taurus called Aldebaran. So a bit above that is where you find Ceres. So to help us out, here in Stellarium, we're actually going to just click on or type in Ceres here. Click right on that, and there it tells you it's right about there. So we can zoom into that here, just to give us a better view. Let's just say we're looking at through binoculars, and you might just see just a little dot, like a little star. And Ceres is also known as 1 Ceres because it was the first, at the time, asteroid discovered. And an asteroid, it has the word aster in it. It actually means star-like, because long ago, when we first saw these, they just look like stars. They're very similar to them, so it has that appearance, and that's where the name asteroid came from, technically. This was actually the first asteroid to be discovered. That's why it's called 1 Ceres, which means number 1 for its old asteroid designation. And it was discovered in 1801 by the Italian astronomer and Catholic priest named Giuseppe Piazzi, who originally mistaken this for a comet and then realized that it moved a little differently and thought at first that it might be a planet, and it was considered a planet for some time. Asteroids were actually added as planets for a good period of time, and then it was put into its own category in 1850 as an asteroid. And then things changed again in 2006 when the term dwarf planet was created by the astronomical community. And I always say a dwarf planet is kind of in between an asteroid and a planet. So it kind of is an intermediate sort of zone. So it is pretty big when it comes to an asteroid, if you want to compare it to other asteroids as it used to belong to. So it became noticeable enough for people in 1801 through a telescope to be seen. So let's zoom into it even more to give us an actual view of Ceres, and the name is in reference to the Roman goddess of agriculture. It has ties to the Proto-Italic meaning of grain, and the word cereal actually is related to Ceres as well, which I always thought that was a fun fact. So it's a very important goddess in Roman mythology. But anyway, it was named after her, and the name Ceres stuck. And eventually Ceres was determined to live inside the asteroid belt. That's that vast field of rocky objects between the orbit of Mars and Jupiter, all these rocks that fill that space left over from the beginning of our solar system. Well, Ceres is embedded right in the middle of that, about 2.7, 2.8 times the distance between the Earth and the Sun. So it's about 2.7, 2.8 AU from the Sun. It goes around the Sun every 4.5 years or so, and it's by far the largest object in the asteroid belt. About a third of the mass of the asteroid belt is inside of Ceres. It's about 580 miles wide, and we didn't actually understand the surface of it and what it looked like too much until quite recently when the Dawn spacecraft, a NASA spacecraft that was launched in 2007, made its way into the asteroid belt, which first flew by and orbited the asteroid Vesta, also in the asteroid belt, and then visited Ceres in 2015, orbited around it as well. And as we've been studying this world, we realize it's a place that has a lot of water. It's a mostly rocky place, but it also turns out to have a lot of water ice on the surface and even embedded inside of it. And it turns out the crust of this world may hold up to 30% of water ice by volume. And we think that there's a lot of briny, very salty water on the inside that seeps out from time to time, sometimes shoots out in what's called a cryovolcano. And as it does so, it can deposit material on the surface. What we found with the Dawn spacecraft as it flew around, looking at the geology, looking at the surface, which is quite interesting, is all these bright spots. And those bright spots turns out to be something called magnesium sulfate hexahydrate. So basically Epsom salt that we found that was really, really shiny. We also found things called ammonia chloride and ammonia bicarbonate. And these briny areas that filled with these materials and possibly water could be interesting locations for life, maybe very primitive forms of life. We're not entirely sure, but it has been very intriguing seeing this and all of these salty deposits all over the surface that shine as these little bright spots on Ceres. So it's an amazing world we've come to understand more and more as we've studied, especially with the Dawn spacecraft. And it being the largest asteroid and the only dwarf planet that we find inside the orbit of Neptune, it's still very, very small. This comparison actually shows us between the Earth and the Moon what Ceres would look like if you placed it nearby. Ceres has only about 1.5% the mass of our Moon. So that really gives you an idea of how tiny this thing is. But it's interesting because left over from the beginning of our solar system. Much like all asteroids are like, these are leftover ingredients that never made it into the bigger things like our sun or like the planets. So they act as time capsules, allowing us to better understand the formation of the worlds and the objects within our solar system. So they're very important to study, and it's neat to find something like this small and this interesting in our sky. So since it's at its closest to us, and it's still pretty far away, at about 163.5 million miles away, or 14.6 light minutes. The light takes about 14.5 minutes to bounce off this world and reach us. And at that distance and at its small size, it makes it a challenging object to find. Again, you need binoculars or a telescope to locate it. And you can use star charts occasionally to find it, or stellarium like this. But if you are looking just above Taurus the Bull and just above the V shape of the nose here, you may find at least a general location of Ceres, this really interesting dwarf planet. And since it's at opposition, it means on the 27th, we can see it all night long from sunset to sunrise. So rising in the east, moving across the sky, and eventually setting in the west when the sun rises the next morning. So hopefully you'll have a chance at some point to find our dwarf planet Ceres, originally the first asteroid ever discovered. Hey, that's it for another edition of our SkyTonight program. Thank you very much for tuning in. And if you're in the area in Daytona Beach, please stop by the Museum of Arts and Sciences and definitely the Lohmann Planetarium. We are running shows daily. And if you want any more information about those programs, please check online and in our social media for that information and for some of our upcoming events as well. So I will say happy Thanksgiving coming up, and of course, happy stargazing.